So in this lab today, we're going to look at refraction. So when you load the simulator, you'll get a screen that looks like this. Click on Intro. And what you get is a little laser beam, which you can turn on by pushing the button right here. And what it does is it shows the path that light follows. So as light travels here through the air, it's going to strike a boundary with water, and the light is going to bend slightly as it goes into the water. Now, some of the light also reflects. So every time there's a boundary, a little bit of light reflects. In this case, most of it refracts. And then what you can do is you can grab your laser beam and you can move it around. So remember, we always measure the angle of incidence from the normal. So in this case, the angle of incidence would be the angle between the normal and the beam of light. We're looking at this angle right here. The angle of refraction is this angle down here. So to help us measure the angles, there's a protractor here, which you're going to grab. And this is probably the most important part of the lab right here. You have got to get this protractor right on the exact right spot. So what you got to do is you got to make sure that 90 degrees lies right on the boundary between the water and the air, and you got to make sure 0 degrees is right on the normal. If you have this slid one way or the other, you might be right on 90 here, but 0 is not on the normal. You're going to measure the wrong angles. So make sure you move that protractor so that this point right down here, the crosshairs, see the little crosshairs on the protractor right there? That has got to be on the interface where the beam of light is hitting the water. Okay? And then you can change the angle of incidence by moving the laser. So right now I've got it on 30 degrees. And you can see that the angle of reflection is also 30 degrees. So that was the law of reflection. The angle of incidence equals the angle of reflection. What we're looking at today is refraction, though. So we've learned that light can bend when it passes from one medium to another because it changes speed. And if you want to see those waves, you can click on this little thing here and you can kind of see the waves, and the waves on the left side slow down before the waves on the right side, which is why it changes direction. But if we go to the ray model, it's easier to measure the angles. So in this case, we have the angle of incidence. I've set it to 30 degrees, and the angle of refraction you will need to measure here carefully using the protractor. All right. When you go to your lab document, it's going to look like this. You're going to put in the month in which you were born. So if it's July, you'll put in 7. And so this right here is the angle of, the index of refraction you need to use for the lower media. So for the upper media, we're going to use air. That's going to be exactly 1 right over here. But the lower media, it's going to be different for different people. So you're not going to have the same as anybody else. So if I'm supposed to be at 1.48, I'm going to move my slider till I get to 1.48. And you can use these to make fine adjustments. But you will not get the correct slope for your lab if you do not make this material down here have the correct index of refraction. So on your lab document, after you put in the month you're born, it'll tell you right here what to use for the index of refraction for the lower media. Once you've got that, you can go ahead and start collecting data. So for each angle of incidence, 0, 10, 20, 30, etc., you're going to measure the angle of refraction. Now, once you've got that done, you can graph it and you'll see it's not a straight line. To get a straight line requires a math model, which we haven't done yet. So I'm going to give you a little bit of a hint. It's actually a big hint. What we are actually going to graph isn't x and y. We are going to take the sine of the angle of incidence and the sine of the angle of refraction. So after you graph your data, what you're going to do here is take the sine. So get your calculator, because if you use the built-in sine in the spreadsheet, it requires radians and your angles are in degrees. So it'll be easier just to grab your calculator. Take the sine of 0 and put that in there. Take the sine of 10 degrees on your calculator, and whatever that is, put that in there. You'll do that for all of the angles of incidence, and you'll also take the sines of the angles of refraction. And when you get that, you'll get a linear math model, which is what we're going to use. Okay? So that's kind of a hint. So just make sure you're carefully setting the protractor in the right place. Once you set it, you shouldn't need to move it. You can change the angle of incidence. So remember, the angle of incidence is the angle between the normal and the laser beam coming in, and the angle of refraction is the angle between the normal down here and the angle and the light beam that is bent, the refracted light beam. Okay? So that's going to be your lab for today.